In this first question, in the warm-up, we have to find the slope of the line. So I will first label the ordered pairs. This is -3 and 4, and this one is 2, -2. Then I create my right triangle. The rise is -6 and the run is 5. So my slope is going to be -6/5. For the second question, we have to find the slope between points 2, -7 and -3, 5. So I'm creating my little table here, and I'm going to say this is my run and my rise, x and y. So the first ordered pair is 2, -7, and the second one is -3 and 5. So if I find the slope, -7 minus 5 is the change in rise, and 2 minus -3 is the change in run, which is going to give me -12/5. Number 3, I'm going to start the same way. I'm going to make my table for my run and my rise. So I write the 4y and the -1, -2 in the table. My slope is equal to -2. So I start with -2. The change in rise is y minus -2. And the change in run is 4 minus -1. If I simplify the equation, I get -2 equals y plus 2 divided by 5. The next step is to multiply by 5. So I'm multiplying both sides by 5. -10 will equal to y plus 2. And if I subtract 2 from both sides of the equation, I get y equals -12, which is my final answer. In today's lesson, we are going to talk about functions, and we are going to decide if relations are functions or relations are only relations. A set of data written as ordered pairs is a relation. A relation is a function if and only if for each input there is exactly one output. So here is a box where my x values, when they go in, they're called input. Then some type of an operation occurs inside the box, and then my y value that comes out after the operation occurring to x is going to be called my output. Some simple operations can be, for example, multiply by 2, add 5, or square the number. So first we are going to pick a few x values. For example, -2, -1, 0, 1, 2, and 3. And I'm going to fill that into every one of these tables. The first operation calls to multiply by 2. So I'm going to multiply every x by 2. So it's -4 for y, -2. 0 times 2 is 0. And then I get 2, 4, and 6. The second operation calls for add 5. So if I add 5 to -2, I get 3. Add 5 to -1, you get 4. Add 5 to 0 is 5. Add 5 to 1, 6. And add 5 to 2, 7. Add 5 to 3 is 8. And the last one calls for squaring the number. So I'm going to do -2 squared, which is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. In this question, the question is asking us to decide if any of these tables describe a function. Since I'm looking at my x values and I only have one x value for each one of these tables, I can only have one y value to each one of the x's. So all three of these going to be functions. For each input, there is exactly one output. On this slide, again, the question is asking us to decide if the relation is a function, and then we need to identify the domain and the range. If I will have input written, we can also call this the domain, and the output is my range. And again, the input is my domain, and the output is my range. To identify, we are going to first have to figure out which one is a function. So for the 4 input, I have a 0 and a 1 output. So for the 4 input, I have 2 different outputs, which makes this first one not a function. When I look at the second one, for the 1 input, I have just 1 output, which is 2. For the 3 input, I have 1 output, 4. For the 5 input, I have just 1 output, which is 4. And for the 7 input, I have 1 output, that is 6. So this one is a function. And for domain, we are going to write 1, 3, 5, and 7. And the range in this case will be 2, 4, and 6. We also use the vertical line test to decide if graphs are representing a function. If a vertical line only crosses a graph in one place, or any vertical line crosses the graph only in one place, it's a function. If any vertical line crosses it in more than one place, then it's not a function. So on question number 1, when I draw several vertical lines, each of these lines only intersect my red line in one place. Therefore, this is a function. When I look at my second example, if I draw this vertical line, I have 2 intersections. So this line crosses the oval shape in 2 places. Therefore, this is not a function. When I look at example 3, any vertical line I draw only crosses it in one place. So it's a function. And my last example, again, if I draw several vertical lines, they only cross in one place, so this is again a function.